Hi friends, so we are into our course, or rather NPTEL course on risk conscious operation management of complex engineering systems. Um, we have completed 11 modules, but we have come to the 12th module, and operation management, there is a increasing trend of using AI tools and methods. It is very important to understand first what are the areas that require AI tool and methods, and second, what are the challenges that we must understand, and then what are the additional domain specific technologies in respect of AI applications are required. And I think by the time we finish this 12th module, that is AI and operations and maintenance management, rather, you know. So I am Professor Prabhakar V. Vardhe, and I am founder and CEO of Center for Engineering Risk Assessment and Management, Mumbai. I am a guest faculty at LTU, Sweden, and I have served almost like 35 years as in BARC, a group called Reactor Group. So that means all my life I have served nuclear systems, plants, operation, maintenance, and then I retired from there as a associate director Reactor Group, and then I did my PhD. So I had this professor, senior professor, Homi Bhabha National Institute, and this is my brief introduction. You can see here. Let us start with what are the 5 modules or 5 lectures getting into this AI models in operation and maintenance management. The first, this lecture will be introduction. Let us understand the background, relative importance, right perspective for AI into O&M, operation management. And then we'll, in the second lecture, we'll see AI model and methods. So this will prepare a technical background for application of this AI, and there could be many applications, but here I will be discussing the operator advisory system in plant control room, anywhere in any industry. There are enough signal and instrumentation that are provided that are meant as, they are called basically main machine interface or human machine interface, and basically the job is to keep inform operator about the status of the plant, and if any actions are required, that also can be effected from control room for the plant. So this is one operator advisory system will be there, and then it will be fourth application will be many of you would not have heard about this subject, prognostics and health management. You understand like this, any engineering component, we want to understand its life. Okay, reliability, availability, maintainability is okay, but we want to understand its remaining useful life, how long it will function, and more important than that is whether it will give any signal before failure. So that means is it possible to monitor signals and predict the remaining useful life, of course with a limited amount of or acceptable uncertainty. So that will cover in a prognostics and health management a systems approach. And so far PHM has been seen as a component of a system structure component specific method, but here I am going to present a system specific approach. That means the plant is there, we have to understand because PHM is a very resource intensive technology. Not only is resource intensive, even R&D efforts are extensively required. If you talk about any component, any system, structural system, engineering system like pump, heat exchanger, breakers. So you have every application will have its own its own challenges. So R&D point of view also it is very challenging, and then we'll see. We all see a lot of news article in the paper about AI, its advances, and what all it can do. But then there are some articles on risk associated with the AI. Of course, risk is inherent component of any entity or any technology that comes. So without the fifth module, our lecture will not be complete. So let us start with the introduction. We all are used to seeing man-machine interaction in operation and maintenance. Whether it is transport or a nuclear plant or a process industry, chemical industry, this man-machine interaction is one of the central component of the system, and this has got basically, if you see in time domain or temporal domain, it has got two situations. One, normal operation, that means it is normal operation means there will be shutdown and all that, but the plant is delivering its output, okay, with a small intervention. And the second thing is aging. Not aging. Before that is any emergency condition, and this is something no, and this is rare. I'll tell you why. Because the emergency condition we talk about it, but there are at least 90% plant which have not seen emergency condition, because the safety provision ensure those things. So safety by design, safety by operation, this is how the safety is built into the system. However, the challenge is that and which cannot be denied, even though all the provisions are there, the situation in control room during emergency, it is something like inducing some cognitive stress on the operator, and then as per the design, immediately operator is not supposed to take any action, at least for let's say for 15 to 20 minutes, because the automatic system they take care of, autonomous system they take care of. But then later on, but then the kind of scenario that exists, because plant is going from a very operational domain to some areas where some intended equipment may come, may not perform, some new type of failures are encountered. So situation is little, and there if we have a system which is an addition to the printed copy emergency operating procedures, rather it is built upon the emergency operating procedures, so that based on the online signal, operator gets the right information, diagnostics, and he knows there is some companion. Of course, it is a operator information system. It is not a closed loop operation. Whatever information is presented to the operator, operator has to take a decision whether it is right or wrong, number one, and number two, whether a closed loop should be formed. That means action should be taken based on this advice. So that's why it is called operator support system. And we cannot ignore this fact that human error, again I am emphasizing, humans do excellent job, but then systems resilience to error, that is something in question, and that gets precipitate when we see the statistics like one document, finished study, it says that humans were involved 84% and serious accident it was 94%. That means even though there are redundant provisions are built into the system, but human factor becomes one of the link in that, or one of the event in that accident sequence. So and then role of AI ML is plant operations. In many areas it is seen, like in transport there are a lot of things going on. Only about the safety critical system, and there is another aspect like security. We talk about operation and safety, random failures. We talk about the random failure, but there are some security risk. It is expected that the way people are using AI ML in other areas, it will do well or rather it a security risk also and safety risk also. So that completes the complete canvas. What is expected from this AI tools, what is the human factor that we have to cover, what are the challenge with the man-machine interface, and what is the importance or the challenge that we have to face in and we have to do modeling. From that point of view, we are talking about the challenge. Now, let's ask a sweeping question. Why AI in operation management? Because we have discussed in a philosophical manner. So, why it is required? So, okay, the plant design. First, let's talk about the design. Provisions do not postulate immediate operator response. So, that means there is a built-in resilience into the plant. Okay, but this is the design intent. Okay, there could be a situation or event when a plant is there, it is a complex, there could be some action that might be required. Even surveillance itself is an human factor. Whatever readings we take during the, so it is okay. The design is given, but in operators availability in plant is a must, and it's vital for monitoring, diagnostics, management, and during plant transient. Plant transient, I'll tell you, the characteristic is the control room is flooded with a number of signals, and then the process parameter reading fluctuating or deviating from its normal position, and then there is a challenge how to correlate or what is exactly happening actually. So human intervention may be required. Now, emergency condition, when we see, they are complex in time domain or in terms of failure, because new challenges might come across, and that poses the cognitive capability. See, in normal condition, if operator's cognitive capability was 1, then during challenging scenarios, like we see in many off-normal scenarios, we are not able to take decision when we are stressed. Stress means that there is a cognitive load. It could be emotional, it could be logical, it could be any decision related thing, but then it is more, and during the moment we end up into the emergency situation, the operator's decision making capability at time might be challenged. And when we have a computer based system to support him to understand what is going on, probably, and since it has been built in the leisure period, looking at plant configuration, different type of situations. So that means in a very robust manner it has been built. So it is expected that this the AI based operator support system or any tool for reliability availability, they will work. Because when you are presenting like let us take the case of precursor monitoring. If I am putting a sensor and then I am communicating that information for at least for important equipment to the control room, that means for me it becomes easier to monitor the degradation, be it a bearing, pump bearing, be it some heat exchanger performance, be it some filter, be it some valve, anything, or electrical equipment, breaker, diesel generator, anything. So it will become easier, and that will enhance the plant reliability, because we have made a decision making capability of the operator. Okay, and we have reduced the cognitive load on the operator to a certain extent. And then the role of AI/ML cannot be overemphasized. It is critical for improving plant performance. We are not talking about only risk reduction. We are talking about even the reliability, availability, maintainability, because we have an improved algorithm available to us, and that can, like the way we are benefiting in other fields, it is expected to benefit even the complex system also. Now, we saw what we are talking about is a role of AI. But if we see the scenario, how in part that function was being made by automation. That means a corrective action based on the plant condition or change in condition will be initiated and effected so that plant is operating in some autonomous mode. But then the question here is, what is the boundary? How far we should go to automation? When there are some gray areas between have automation and no automation, then one has to take a decision. So, but then the aim of automation was also to reduce the human error, or rather chances of human error. Okay, and we use automation where things are very process behavior or system behavior or component behavior are very well understood, and they are operating to clear the offsets, valve will open and close depending on the level. So to that extent it is okay, but when it becomes more complex, probably the role of AI enters. So let us understand what is the role of automation and what is the role of. So let us say we have a operator support system, that is intelligent support system, and human intervention. You can see it is not closed loop, it is affected here, okay, and through so emergency operating procedures or manuals have been implemented, and then we can react, and safety and reliability, I would say, goal both are ensured. So here operators, this particular thing, it has got a supervisory role. Okay. Now look at the role of automation. Automation operates in a closed loop, like here we have automation, design intent, failure, manual action when there is no automation. So here human interact, and then safety and goal. So we have two inputs now here. Automations, one signal will come and manual action will be followed, or automatic action will be followed, and then emergency procedures are there for operator, and safety and goals and also. So you can say operational objective and resources that are there that lead to automation. Okay, and then operator is basically without operator support system or AI were also working, but then here we have automation and we have manual action. So that's how we ensure the safety and goals here. Okay. Now let's say role of human factor, automation, industrial artificial intelligence, how it has evolved over the years. Let us start from when the First World War, Second World War, then industrialization started and all that. So let us say when the systems or plants are built, we provide human machine interface. Instead of calling man machine interface, we call them. So that is something, it is there even now also. It is getting, so it is a, I will say state, it is a advanced stage, that is a status as on today, and this is the time. So this particular evolution is a function of complexity and criticality. Okay. So the system became more and more critical. So then it is man machine interface, depending on the plant mimics and those logics, they were insufficient, and then role of automation came into the picture. In fact, here also automation was there, but it was very negligible amount. But then later on, when plant became complex, role of automation came. AI was not there. So if the complexity increased more, then we had this HMI. This role got HMI role got distributed as HMI, automation, and AI, and this role is going to increase. It's a matter of time when we have more and more confidence, even the automation or digital system. Let us try to understand with the application of digital system. The system started with the very I think 40-50 years ago, or maybe it was a wall based technology. From there we moved to solid state technology, and then we moved to digital technology. Even today there are some operation about digital technology, but they are being used with certain redundant provisions so that the safety functions are not compromised. But then finally digital systems have entered into the process part of the thing, and with a care they are being incorporated into the safety domain also. The same thing is going to follow. New technology, people are cautious, then later on we shake hand, have more watch on those systems, and finally we adopt it. And probably AI is waiting that period, but it's going to happen because the advantages are enormous. So role of idea is to, one more important technique is there to reduce the design inherently safe systems. Inherently safe means in terms of material, in terms of process phenomena, in terms of autonomous nature of the system, so that the system is safe for extended period of time, let us say 12 hours, 13 hours actually. And that's how we are talking about the small and medium reactor, at least in nuclear domain, and there the material thing, that is fuel and all those things, with having a high resilience, and then passive systems, that means it will be operating without any active components. And then finally the plant, in plant, if there is some emergency, if some phenomena is built in, there will be a built-in physical negative effect which will further bring down the plant severity to lowest level and avoid the accidents. So, we have seen the canvas as far as operations are concerned. But then we say that role of human is going to be there, whether it is a remote control room, local control room, or whatever. Supervisory role will be there, and that moment came from Industry 4 revolution, and this Industry 4 revolution has led to learning and development. Okay, so how to enhance this learning coefficient? Or learning built into the system. So that is where the AI technology comes into the picture. We train an artificial neural network the way we had trained operator on simulators, and then developments were based on that. That means emergency operating procedure were transformed to ANN modules, and then finally and then when they operate in online mode, so that means earlier it was thought that humans have only learning capability and cognitive capability, but then the system also in the context of the plant operation and maintenance, or they have learning capability, and they can take action in a closed loop. Okay, now it is going through advisory system, but then the learning and development movement after Industry 4 revolution is already started, because we are now facing a dynamic structure where training and development are based on feedback from operations. So this is one additional lesson that even at the organizational level, this learning phenomena should be continuous, whether it is small event or big event. There should be sessions, and that should be embedded into our plant culture in terms of reflecting them into the design document, operating document, and then our simulator sessions. Now slowly simulators are becoming the plant's integral built into the system, and goal is same. This training will be safety, because safety is a overriding factor, and then reliability. We have to deliver it also. That only justifies the investment made into the building a plant or operating a plant. And now again the time has come for quantified metrics. Safety is not a quantified parameter, but if risk is a quantified parameter, use the quantified metrics. Use the quantified metrics of reliability, use the quantified metrics of availability, and then this metrics and present them with uncertainty, because uncertainty is part of any system that we build. And role of AI has been promising given this backdrop actually, because we can develop, it's not only ANN, it is all fuzzy artificial neural network. They embed the knowledge of in terms of F and their rules, and then artificial neural network, they do pattern recognition. So it is an excellent opportunity to handle a scenario which was evolving very quickly or very fast in time domain, number one, and then do diagnostics using production rules that are available to us, whether it's fuzzy rule or crisp rules that are available to us. So we have a complete now canvas that we are building to have application of artificial neural network. Now, since we have landed into AI, let us understand artificial intelligence. This has evolved somewhere at the beginning of 20th century. So, what is this? When ANN came into the picture, there were a lot of resolution. ANNs were not liked actually, especially when I did my PhD in 1996. I had to really defend ANN. Why? Because whatever ANN I had developed, and the application operator support system that I had put up, I was very happy that ANN is performing the way the logic operates, the way cognition and logic together they operate, and the way system complexity poses problem, and we solve them. So what is ANN? And then lot of names were given to it. So let us see AI. What is the perspective on AI, machine learning, and deep learning? Now here we have a artificial intelligence, a complete domain. And then machine learning and deep learning are part of it. Artificial intelligence can use any technology statistically, or so many tools are there, and they reflect how a human model of rationalizing, human model of taking decisions. So anything that do the statistical and other methods, so it is a complete, and of course these are there actually. Then the machine learning came. Machine learning came. In fact, AI is a perfect example of machine learning and deep learning. Why machine learning and deep learning? Both I'll explain. So AI provided a broad framework for this. How we can see the technical component, or how we can get inspired. Artificial intelligence. Intelligence is a human specific thing. So how we can make intelligent machines. So that is why we had artificial intelligence. Machine learning. Machine learning came because the AI can learn from the data or patterns we feed it to it, and then it whenever and testing is a part of the machine training AI tool, and seeing the that is called recall factors vectors. So we put them to the new condition and see whether they are able to predict the result the way a human does, or better than because here the phenomena will be happening in a very processing will happen in a very short time. Sometimes it is just pattern matching, because 99% of the patterns have been trained, and if you put a new condition, something with a deviation, ANN can perform. And then the machine learning is there. Machine learning is basically machine is learning. Now it is capable of any new situation or any trained situation you see. So human also operate like this. What if you give training, they do the job, so they are learning. And if you put a new situation to them which they have not encountered, they try to see what they have learned and then try to bring those situations to one of the thing. Otherwise they say, of course there is again a possibility of that you don't know. So like machine also can say don't know, but then machines are capable of learning. They will say, I don't know, do you want to train this new condition? And if you say yes, the machine will learn that thing, and that is what happens in the human also. Only thing is machine do a job in a very faster way. Deep learning. Deep learning has got a very recent terminology that we used to the ANN only, but there were some problem earlier. Problem was we were using only one, I'll tell you the configuration. So hidden input layer, output layer. So one layer was there. So now multiple layers are used, and now I'll come back to my initial statement. My NN was performing well. Why others? So what is the kind of data you give at input to train the network? The result will be commensurate. So if data is not good. So now in deep learning we have pre-processing provision. That means data filtering, pre-processing, feature accession. So, take the case of simple vibration data. If you provide an input and then ask NN to train, it might get trained, but it will mug up that thing and it will not deviate from there. But then if you tell them, okay, there are two frequencies when the inner race fail, outer race fails, and they go to amplitude goes to. So, if you put their knowledge, the point I am trying to making is domain knowledge is very important for building ANNL, and that domain knowledge has got reflected into data science, data analytics, and now ANNs are performing well. Okay. So, the one statement I would like to make here is domain expert should be part of any intelligent algorithm that are being built for a given application. Now, overview, we got operation and maintenance. Operation specifically will be operator support system. PHM will be, which will be discussed in the next lecture. So, background is ready for that. Role of AI in O&M you would have understood, or maybe next 2 or 3 presentation will bring you very close to this idea. Role of automation, where we stand for automation, and what are the limitation of automation system, and what are the advantages with the AI. So, it is a very complex subject, but we can discuss it at least. And then we discuss perspective on human machine interface, automation, AI, ML, and we also understood in a broad sense difference between AI, ML and deep learning.